Good morning, folks. For this recording here, we're going to go through two different topics. You can see here we're going to go through some angle pair relationships, and then we're also going to go through and measure and classify angles. So we'll start with this measuring and classifying angles. An angle is made up of two rays. You can see here that we have these two rays that meet at a common point. That common point is called your vertex. The vertex is kind of like that turning point when in reference to an angle. There's a couple different ways that we could name angles. When you name an angle, you always want to focus on the points that are labeled there. So one way that you can label it is based off of the vertex. In this case, the vertex is A. So I could say that this is angle A. But the reason we usually don't state just angle A is because if I just say A, then that can create some confusion in terms of where that angle is. So typically we use three of the points to help us identify where that angle is or what that angle should be labeled as. So this one here, we could say angle CAB. We can state angle BAC. We just can't say something like ABC or ACB because the vertex always goes in the middle of how you label it. So we can, for this one, we can either say angle CAB or angle BAC. So name three angles in this diagram. For this one, I would not state angle X, and that's because angle X could be the small one here, this small one down here, or it could be the whole thing. So we're not going to use angle X in this instance. Instead, we would use three letters. So I could use angle WXY as long as the vertex is in the middle, or I could reverse that around and say angle YXW, or maybe we want the whole thing WXZ, ZXW, YXZ. There's quite a few different angles we could label there. And also with this one, I wouldn't state angle N, and that's because angle N, we don't know if it's this one, or the whole thing. So I would probably state something like angle MNP if I was referencing the whole thing, or reverse it around and say angle PNM. Or we could say angle MNO, ONP, or reverse those letters around as well. Now the protractor postulate, this is something that's just kind of given. It's not something we can go through. It's not like a theorem that we can prove. So the protractor postulate allows us to measure different angles. It's good to be able to measure an angle. A lot of times if you're, let's say we're working on construction, if we're working on construction, we need to know exactly what angle to cut pieces of wood. So we need to be able to measure those out. So the protractor postulate, what we do with our protractors is we take the center of our protractor and we line that up right on the vertex of our angle. And then you take either one of the sides and you line it up with the bottom of your protractor. Now you have to pay attention to which side you line it up with. Because if I use this, if I line it up with this side, then I need to make sure I use the correct numbers when I'm measuring around to the final side of your angle. So if I'm measuring this around from this base, that means I would have to use the inside numbers 10, 20, 30, 40 all the way around to right here, which is 140 degrees. This angle is 140 degrees. Now, if I would have lined it up on this other side, that means I would have used these outside measurements to get the measurement of my angle. So pay attention to how you line it up and which side you line it up on. So measure and classify the angles. Not sure why this carried over. Just ignore that. These angles here, so this acute angle. An acute angle means that it's going to be less than 90 degrees. So an acute angle is less than 90 degrees. So it's going to be those tiny little acute angles. So it would be an example of an angle that is less than 90 degrees. A right angle, you're going to see that little box in the corner to show you that it is 90. That's the symbol that we use to show that it's 90 degrees. So a right angle is going to be equal to 90 degrees. Make sure I put my box in there to show that it's 90. Obtuse angle is going to be greater than 90, but less than 180. So an obtuse angle is greater than 90 degrees, but it is less than 180 degrees. So an example of an obtuse angle, that's about obtuse right there. I had to take a guess, that's probably about 90, 100, 110 degrees maybe. And then a straight angle is just going to be that straight line. Our vertex in there. And a straight angle will equal 180 degrees. So this one over here equals 90 degrees. All right, so here we're going to measure and classify the angles. If I want to measure KHJ, let's find K, let's find H, and let's find J. So I'm going to place my protractor on the vertex. And since I'm measuring from this base right here, that means I'm going to measure upward. And I would use these inside numbers, 10, 20, 30, 40, 50, 60, since it's right in between 50 and 60. My best approximation is that this here is a 55-degree angle. Don't forget to put your degree mark. GHK, here is G, here is H, here is K. Since I'm laying it on this side, I'm going to use these outside numbers to measure up and over. And this comes out to 10, 20, 30. It's right in the middle, so I would say that this is 125 degrees. All right, so you kind of get the gist of how you can measure these out. Now, some of these sides might not be long enough with whatever protractor you're using. They might not quite be long enough. So you might have to extend them a little bit so they actually cross your protractor. So just take a straight edge and just extend those lines outward so that they actually cross over or through your protractor. All right, the angle addition postulate then states that anytime you have a ray on the interior of your angle. So here's my angle. My whole angle is RST. And what the angle addition postulate says is that to make up the entire angle, I can add up the pieces. So the parts make the whole. That's basically what the angle addition postulate says. These parts here, if I put those parts together, it's going to make this whole. So the angle addition postulate specifically tells us that if I take these pieces, the measurement of the pieces, and add them together, it's going to equal the measurement of the whole thing. It's much like the segment addition postulate, where if you take the measurement of the pieces and add them together, it's going to equal the whole thing. So how can I use the protractor postulate here? Well, this tells me that the measurement of the pieces, if I add up the measurement of the pieces, when I add up the measurement of the pieces, it's going to equal the whole thing. So once I set that up and put it all together, I have an equation that I can solve. So if I take this equation and work it out, I can combine my like terms, simplify, and solve. So 2x and 4x, when I put those together, give me 6x. 10 and negative 3 would give me a positive 7 equals 145. So I would subtract 7 from both sides. So I get 6x equal to 138. Divide both sides by 6. Keep in mind that this just gives me x. It doesn't give me the angle, it just gives me x. So that would be 23. So x is equal to 23, but pay attention to what they're asking for. If they're asking for instance, the measurement of LKM, if they want the measurement of this angle right here, that means I need to take 2 times 23 and add 10 to it. So 46, 56. This angle is 56 degrees. So you might not be asked for x, you might be asked for the angle instead. And then you're also asked for this angle down here. So I would take 4 times 23 and then subtract 3, and that would give me this other angle down here. Again, using the angle addition postulate. So I know that if I add up the pieces, when I add the pieces, it's going to equal the whole thing. So when I add up those two pieces, it's going to equal this whole entire angle, which we are told is 72 degrees. So when I add up the pieces, it equals the whole thing. Again, combine your like terms, simplify and solve. Pay attention in case you're asked for x or you're asked for the measurement of angle XYW, or you might just have ZYW. This right here means the measurement of XYW, but this also right here means the measurement of ZYW as well. So both of those mean that they are looking for the measurement of that angle. All right, congruent angles. You've already been introduced to congruent angles, but it's two angles that have the exact same measurement. If you take a look at this here, when you put an equal sign, it means the measurement. So it means that their measurements are equal to each other. The congruent sign means that they're the exact same shape. So these two angles are the same shape. These two angles, if they're the same shape, then that means that they also have the exact same measurement. So equal sign deals with measurements. Congruent sign basically means the exact same shape. So measure and classify this because you see these little tick marks. That little tick mark is a symbol in geometry that indicates they are congruent to each other. So if they are congruent, that means that they are the exact same measurement. So I know that the measurement of angle XYW is the exact same as the measurement of angle WYZ. And the reason I know that is because those little tick marks in there, that's a symbol in geometry that means congruent. So in the diagram at the right, we're told that YW bisects. Hopefully you understand what bisects means. YW cuts it in half. So instead of saying bisects, we could say cuts it in half. So if XYW, if this one is 18 degrees, then I know for a fact that this one would have to be 18 degrees as well. So pay attention to what you're asked for, because we are asked for XYZ. So XYZ, we're asked for the whole thing. So the whole thing, the angle addition postulate tells us that all we need to do is add up the pieces to get the whole thing. So 10, 20, 36. 18 plus 18 means the whole thing would be 36 degrees. So that goes through, measuring and classifying angles. Now we're going to focus on those angle pairs. So the relationship between angles. So two angles are complementary. When two angles are complementary, it means that their measurements add up to 90 degrees. So when two angles are complementary, it means that their measurements add up to 90 degrees. Now if they're supplementary, that means that their measurements add up to 180 degrees. So two angles, complementary, 90. Supplementary, 180. Complementary and supplementary angles, they can be adjacent to each other, they can be split apart, they don't have to be right next to each other. So complementary and supplementary angles don't have to be right next to each other. So adjacent angles, you can see that adjacent angles are two angles that share a common vertex with each other and a common side. But they don't have common interior points. So if I had to draw an example real quick, here's my total angle, and then if I just put an angle, or excuse me, if I put a ray in there, adjacent angles, they share a common side. So here's their common side. They share a common vertex. Here's their common vertex. But they do not share common points. So they don't, like this point here is not inside of both of these, or if I put a point here, they don't share that point. So adjacent angles are right next to each other. Here's an example of complementary adjacent angles. So the two angles are right next to each other and they add up to 90. Here's an example of non-adjacent complementary angles. The two angles add up to 90, but they're not right next to each other. They don't share this vertex. So adjacent, they share this vertex, they're right next to each other, they add up to 180. Remember, supplementary means 180. Non-adjacent, they don't share this vertex, but they do add up to 180 degrees. In the figure, name a pair of complementary angles. So that means that they have to add up to 90 degrees. So complementary, if I take angle CAB, this one, and angle RST, both of those add up to 90 degrees. These two are complementary to each other. A pair of supplementary angles with each other would be angle CAD. So this one, and if I add it to this one, they add up to 180. So angle RST. Now if I wanted to Identify a pair of adjacent angles. A pair of adjacent angles, they're going to share a vertex. So two adjacent angles would be angle CAD, but also angle CAB. Name a pair of complementary, supplementary, and adjacent. Again, look for those angles that add up to 90, look for the angles that add up to 180, and then look for the angles that share a vertex. So these two share a vertex, 49 and 131. These two are supplementary. And then 49 and 41, those two are complementary. Given that angle 1 is the complement of angle 2, that means that they add up to 90. So if these two add up to 90 degrees, to find angle 2, all I would have to do, so I know that angle 1, adds up to plus angle 2 equals 90. So if angle 1 is 68 degrees, 68 degrees plus x equals 90. And you can hopefully use a little bit of common sense here and say, all right, all I need to do is just subtract them. So I find out that the measurement of angle 2, I would subtract the 68 from both sides, and I find out that the measurement of angle 2 would be 7, 8, 9, 22. 22 degrees. Don't forget your degrees. Now, since these are supplements, I know that they add up to 180. So I would have to take this and subtract it from 180 to get the measurement of angle 3. Two adjacent angles are a linear pair if their non-common sides are opposite rays. So again, remember what an opposite ray is. It means that it points in opposite directions. So the two adjacent angles are a linear pair if their non-common sides are opposite rays. So if I have two opposite rays, so here is a ray, here's an opposite ray. See how the whole thing is 180 degrees? So if I put a ray in between there, I just created adjacent angles. I created adjacent angles that are supplementary. Therefore, they have a special name called a linear pair. So those two angles have a special name called a linear pair because they are supplementary to each other. A vertical angle, though, is when the sides of two angles are opposite rays. Another way of stating that is to draw two lines that intersect each other, and the vertical angles are on opposite sides. So this angle over here, angle 1, and angle 2 are vertical angles. So these two angles, their sides, form two pairs of opposite rays. So here's a ray and here's a ray. Here is a ray and here is a ray. So all you need to remember is that vertical angles are on opposite sides of each other. Describe the angle pair relationships here. Since these two add up to 180 degrees, I can call them that special name, a linear pair. And then over here, 4 and 5 are on opposite sides of each other, so I can call those vertical angles. 3 and 6 are on opposite sides of each other, so I can call those vertical angles as well. The measure of one angle is 5 times the measurement of the other angle. Find the measure of each angle. So if I want to set up this equation, this would be an algebraic equation. Two angles form a linear pair. So I know that these two angles, angle 1 plus angle 2, needs to add up to 180 degrees. The measure of one angle is 5 times the measure of the other angle. So we can just grab them and state whichever one is which. Doesn't matter. So if I called this one x, this one would have to be 5x because it is 5 times the measure of the other one. So if one is x, the other one would be 5x. Since they are a linear pair, I know that 5x plus x has to add up to 180. So now when I go through and solve this, 6x equals 180. divide both sides by 6 and we get x equal to 30. So x is 30. If one angle is 30 degrees, my other angle would have to be 150 degrees because it is 5 times the measurement. So if one is 30, the other one would be 150. All right. Folks, that completes the lecture, the video on angle pair relationships as well as measuring angles.